Hello. Looks like there might be a person or two watching. So basically how this is going to work is if you look in the description of the video, you should see a link to a chat room. And oh no, an error occurred. Should be working. Okay, there we go. Alright, looks like it's online for me. Hopefully if you had a problem you refreshed. Anyway, back to what I was saying. There's going to be a link in the description to a chat room where you can ask questions, so I'll be checking that. And so, like, any requests you have or any questions you have, anything specific you want to look at, just go in the chat room and log in there. It's going to ask you to log in as somebody. Just log in as a guest. There are options to log in as like through your social media stuff, but don't do that. Just log in as a guest, and it won't take any personal information about you or anything. So there you go. So I'll be watching that chat room, and once I see people start to ask things in there, I can go ahead and start answering questions. So don't be shy. I'm here to help with anything. It could be a vague question, a specific question. I'll work with you and we will figure something out. So for physics, it takes a lot of practice and a lot of sort of guidance. The best way for me to help you is for me to see your work and then to comment on it. But the second best thing is something like this, where I can just take your questions directly and maybe try to clarify something. So there we go. Now I have the homework also that I can pull up and my iPad screen, so it's not going to just be my face talking. Okay, so let me show you here. So here is the homework. Let's pull it up. Alrighty. So I have it ready to go if you have any questions specifically on that. Alright. I know I told you to do number 3 for tomorrow to the best of your ability, and so I can address any questions about that too. Alrighty, and let's switch to something else. Let's go to my iPad display. Here is where I'll be writing everything. Sometimes I have some problems with this shutting down and whatnot, but usually it's pretty good. I can just write stuff here. There we go. Okay. Good. So once again, there's about a 30-second lag, so whenever you do get into the chat room and ask a question, it'll take me about 30 seconds to see it. Right now, let me just type something in here just to make it alive. So what you need to do, once again, if you want to use the chat room, just go to, sorry, let's go ahead and bring this up. Go to the description below the video, and then go to the link that I posted in there. All right. Otherwise, I don't have a whole lot to go off of if nobody asks a question. So hopefully somebody's watching out there and asking a question. Okay. So it's a bit boring for me just to sit here and ramble. So I'm going to go ahead and let's look at something from the homework. Maybe just like from the homework you guys have already turned in, we can look at number 1 and number 2. Any questions? If somebody has a question about number 3, they can just ask that in the chat room, and then I'll be able to answer your question. And if for some reason you can't get the chat room to work, what I'd like you to do is go ahead and send me an email, and I can just answer your questions through that. I have my email here as well. All right. So without further ado, let's go ahead and bring up the homework. And let's talk about it. Okay, here. Alright, so first problem, a captain sails his ship in a straight road at a constant speed. The position as a function, the position function for the boat, x of t is 5t, where x is measured in meters, t is measured in seconds. The ship leaves the port at time t equal to 0. Okay. So just like to highlight a few things here. This means that at time t equals 0, if the ship's leaving the port, this position function that I just highlighted means that at time t equals 0, x is equal to 0. So the origin for this coordinate system, or wherever x is equal to 0, is at the port. Okay. So it first says evaluate x of 0. What is the meaning of x of 0? We just talked about that. It is the starting location of the ship, and it's the location of the port. All right, part B here, we have make a sketch of the situation including coordinate system. Okay, so let's go ahead and bring up the iPad and do that real quick. Here we go. Okay. So here we go. Should be up. We have a port here. All right, I'm just going to put a big port. Okay, and this is, I guess, the water is traveling along. So some water. All right. And we're just going to be traveling in a straight line. So I'm going to use the x-axis, define an x-axis, positive x here, which is given in my position function, given by my position function, x of t is equal to 5t. That gives the location x of the boat at any time t. Alrighty. So let's go ahead and answer these questions. The first one, make a sketch. There we go. Part C, what's the independent and dependent variable involved? Well, the dependent variable here is the coordinate x of the boat at any time t. So here's the boat moving along some arbitrary time t. He's at the position x, right? And this is t equal to t here. And over here is t is equal to 0. All right. There we go. So he's got the boat moving along. The independent variable here is the time. So any time greater than 0, this boat is going to be up from here, is going to be moving this way, right? And so this gives us the position, the x-coordinate of the boat at any time t. So it gives us a few examples here. In part D, if we go ahead and plug in t equal to 2, it would give us the x-coordinate at t equal to 2. So part D, x at the time 2 seconds, if t is measured in seconds, is 5 times 2 meters, so 10 meters away. Now I left off the units here because explicitly in the direction it says x is written in meters. Okay. All right. Wow, this is cool. Will the video be there after the live feed ends? Okay, I'm just seeing a guest. All right, and guest 289. Yes, it will be there after the live feed ends. Yes, it will. Okay. So that's great. Somebody's there. So once again, I'm about 30 seconds behind you, or in front of you. So go ahead and ask a question if you have one, specifically on the homework, like 1, 2, or number 3. Okay. So guest 289, I'm depending on you to give me some feedback, ask me a question, whatever. All right. So until then, I'm just going to go ahead and keep going through number 1. I'm at part D right now. Whoa. My puppy's having a little bit of a temper tantrum. Sorry about that. Okay. All right. All right. So let's keep going through. Let me pull up the homework again here. Alrighty. Let's pull it up. Alrighty. So here's the homework. We just did part D. We found the distance traveled by the boat. That's equal to the x-coordinate, right? It leaves from the port. So you take the difference in the x-coordinates from x equal to 2 and x equal to 0. We start at x equal to 0, so it's just this x-coordinate is also going to be the distance traveled in this problem. Part E, there's a misplaced pipe at the location 2,000 meters from the origin in the path of the boat. How long will it take for the boat to hit the pipe? Okay, Mr. Saeed. All right. So, Mr. Saeed, if you have any questions, just leave them in here. Anything specific about number 3? Probably is what you're wondering, but if you were doing any of these problems from before, 1 or 2, and there's a part that you want to focus on, just let me know. Okay. Let's see here. E. This is a misplaced. All right. So there's a misplaced pipe 2,000 meters down the line. Okay. So here's our x coordinate again, and about 2,000 meters down from the port, we'll just put it there. Okay. There's a pipe, and hitting a misplaced might not be very serious, but in our example, let's pretend it's a bad situation. Okay. So it's going down at 2,000 meters, hits the pipe. And the question is, okay, let me go ahead and bring this up. Otherwise, you can't see what the heck I'm talking about. All right. There we go. All right. So we're going down. We hit this pipe at 2,000 meters. And the question is, how long will it take for the boat to hit the pipe? Okay. So we don't know the time right now. And that's okay. What we say is let t be the time the boat collides with the pipe. All right. Good. Okay. Then we know x at the time t must be equal to 2,000 meters. Alrighty. Alrighty. So what we do is we get our position function, which is this guy, x of t is equal to 5t. And we say, okay, I'm going to say x at t, the time t we're interested in, the time the boat collides, is 5 times t. And we know x at that time must be 2,000. Okay, so 2,000 is equal to 5t. Or in other words, the time it takes is equal to 2,000 divided by 5. All right, and let's put time on the left side here. 2,000 divided by 5. That's a tough one. I think it's 400. Yes, 400. Math skills not so good, but I think I got that one. So that's measured in seconds. All right. Okay, so how we doing here? Mr. Saeed, am I making any sense to you? Do you have any questions so far? Is this somewhat similar to what you did? Let me know. I'm going to start this next part, and then by the time you hear me say that, I'll be somewhat through the next part. So, all right, just let me know. Okay, let's get to the next part. Let's bring it up. Share. Okay, so part F. Ship collides with the pipe. The engine of the ship is damaged. The ship now travels with this position function, where t equals 0 has been reset to occur at the time of the collision. Okay. The ship continues to travel in the same direction toward a rescue boat to unload its passengers. The rescue boat is 1,000 meters away from the pipe. Okay. And now it just says to update our sketch from part B, include any new features. And then we got some questions. Why is the coefficient changed from 5 to 2? Why does 2,000 appear there? So I just really want to test whether or not you understand each sort of little piece of this equation. Okay. And so let's go ahead and look at that. Let's go. Alrighty. So there we are. Okay. So this is going to be part F. Now we have x of t equal to 2t plus 2,000. Alrighty. And so let's update our sketch. So let me get the sketch from before, which is here. Just going to copy and paste that over. Well, let's see here. Should I just use, yeah, let's use this one. It's fine. Hit copy. And here we go. So we reset time t equal to 0 now here. t is equal to 0 there, right? And what we can do is test that if we plug in x equal to 0, or rather not x equal to 0, but x at the time 0, we should get 2,000. So we get 2 times 0 plus 2,000. 2 times 0 is 0, and we do get 2,000. So our new starting position at t equal to 0 is going to be 2,000 meters. All right. So what we do now is we go ahead and look at x of t. All right. And this should just about update our sketch. What we're going to do is include one more piece. So somewhere down here there's a rescue boat. Let's put RB for rescue boat, okay, at some other position. This is still x equal to 0 here. This is still the x-axis, right? Just reset the time equal to 0 here instead of over here, right? Alrighty. So what else do we got here? Why is the coefficient changed from 5 to 2? Here, all right. So that's a good question. Remember that coefficient in front of t, so before we had x equal to 5t, this was the old one. I'm going to write it in red, for example, x of t is 5t. Remember, this coefficient is related to the speed. In fact, it is the speed. In this case, in meters per second, since x is measured in meters and time is measured in seconds. So now this 2 means our speed is reduced. So if the engine is damaged, right, suppose that's true, and we're now traveling at a slower speed. Okay. All right. So the significance is we're now traveling at a slower speed. That would be the response for this part 2 here. Slower speed because of the damaged engine. All right. All right, Mr. Saeed, if you're still there, just send me say something in the chat room, just to say hello, just to let me know if anything's unclear, if anything's making sense. If I'm talking another language and you don't understand, just let me know. All right. Okay. So the part 3 of this question is, why does the 2,000 appear at the end of x of t? Well, we kind of covered that, right? Well, it's because we set t equal to 0 here now, right? And the starting position would now be 2,000 meters, right? This location, x equal to 2,000, right? Before, our starting position was all the way over there, right? Remember, what we're referring to as our starting position is not where x is equal to 0, but rather where t is equal to 0, okay? So that is what I'm saying there. So for part 3, x at 0 is equal to 2,000, right? Meaning t is equal to 0 at the location of the ship, or of the pipe, rather. Okay, because it was reset to t equal to 0 there. Alrighty. So what else is going on here? Yeah, still here. Alright. Nope, so far so good. Okay. Can you skip to number 3 after you finish number 1? I can do that. Alright. So we'll be skipping to number 3 after we're done here. Let's just wrap it up. Alright, number 4. What is the x-coordinate for the location of the rescue boat? Oh, and Mr. Saeed, by the way, send me the coordinates for that 8-ball that I had you guys write down, because I don't have that sheet with me. So if you have the sheet with you, just write down the coordinates. Oh, okay. Right. Okay. So I collected your homework, so you don't have a electronic copy. But what I do have is on RenWeb. You can go up. Oh, I don't have it on RenWeb either. All right. I need to put the physics homework on RenWeb as well. All right. So it'd be great if I could show both of these at the same time, but I'll just have to flash back and forth. All right. So let's go down to these parts down here. What is the x-coordinate location for the rescue boat? Well, the rescue boat, so that's this part, is 1,000 meters away from the pipe. So on our sketch here, we can put that this is an additional 1,000 meters away. All right, and let me go ahead and do that, show you on this screen. We're 1,000 meters away, and that means we can update our x-coordinate or we can write our x-coordinate, right? It's going to be 2,000 here, plus another 1,000, so this x-coordinate here will be 3,000. So the x-coordinate of the rescue boat, should be an S here, is at x equal to 3,000. All right, meters. Good. Right. Okay. Well, for part 3, when I do get there, for number 3, I'll just make up my own coordinates. If you have the papers, no problem. All right. Next part, we have after it hits the pipe, how long will it take the ship to reach the rescue boat? Okay. Fair question. So what we're going to do is go ahead and say, well, we don't know the time, but we'll say it's sometime capital T. Sorry, I brought that up again. It's sometime capital T, the boat, the damaged boat, reaches the rescue boat, okay? And so this time is actually going to be measured from this T equal to 0 here, all right? So we're going to measure how long it takes to travel from here all the way over to here, all right? Let's measure how long that takes. So let's go ahead and do that. Alrighty, so here's our position function for 5. It's going to be the same as the damaged boat. It's going to be 2t plus 2,000. Alright, everything's looking alright. Okay, and then what we're going to say is let t be time when rescue boat is reached. All right. Okay, so that's saying that x at that time t is equal to, well, it's the x-coordinate of the rescue boat, which is 3,000, right? 3,000. So the x-coordinate of our ship at the time t, the time when we reach the rescue boat, 1,000. So let's take our function and evaluate it at that time. 2t plus 2,000, just plug that in. And that must be equal to 3,000. So do some algebra here to solve for the time. 3,000 minus 2,000 is 1,000, which is equal to 2t. And this tells me that the time it takes to reach the rescue boat from when it crashes is going to be 500 seconds. Pretty quick, all right? And so let me go ahead and pull up the last part on the sheet. Okay, here we go. And so what we have is, what is the total time elapsed from the moment the ship left the port to the moment the ship reaches the rescue boat? Alrighty. Good. So let's go ahead and look that up, or figure it out, rather. Alrighty. So let's look at a picture here. Hold on one second. I think you got an email from a student. Okay. So we have another student watching. That's good. So the student is, so if you're just joining us now, what you can do is go to the description. So let me go ahead and bring me up. Okay. So if you're just joining now, go to the description below the video and go to the chat room in there. And in there you can ask questions about anything. We're just finishing up number 1. You can watch the rest of it later. Just when you get into the chat room, just log in as a guest. Don't log in through any social media, so that way you're still anonymous. And lastly, let's see here. There's something else I needed to say. Just don't be shy about asking questions. Ask whatever. Whether you think it's general or not, we'll figure it out, and I'm here to help. All right. So I'm going to go ahead and go back to answering this one, which is, what is the total time elapsed from the moment the ship left the port to the moment the ship reaches the rescue boat? Alrighty, and let me go ahead and bring up my iPad. Alright, so, oh yes, the last thing I wanted to say is there's a 30-second delay between me and the chat. So when you write something, I don't see it for at least 30 seconds. All right. Anyway, the last problem is saying, okay, add together the time it took for the boat to hit the pipe with the time it took for the boat after it hit the pipe to reach the rescue boat. Okay? Well, in part, let's see here, E, I believe. In part E, we calculated how long it took to get to the pipe. 400 seconds, 400 time units. And then down here, we calculated that it took 500 to get to the rescue boat from the pipe. And so, what we do is we add these two times together to get the total time. All right, so this is the last part. I think this is part 6, right? Total time is the sum of those two times, which is 400, I believe, plus 500, which is equal to 900 seconds. All right. So we were only out there, boat was only out there for a few minutes, right? I'm just checking the values. So yes, we did get 400 here for that first time, 500 for the second time. So the total trip was 900 seconds. Okay. Very good. Mr. Saeed asked if I answered this question. Yes, I will look at number 3 in some detail after this. I can't expose everything. That would be an unfair to those who didn't watch the video. I will look at number 3. Okay? Alrighty. So let's go ahead and go to number 3. Alright. And once again, if you're just joining, you can join the chat room in the description below the video. There's a link to the chat room. Just sign in as a guest, and you'll be able to communicate with me through there. Yeah. Okay. So let me just reply to this quickly. Yes. We'll look. Number 3. All right, let's go. So number 3. Let me go ahead and bring up the question sheet for number 3. All right. 2 students are playing a game of billiards. See the sketch below. I'll bring up a sketch. I don't have it on the sheet. Cue ball was shot from the top right pocket towards the 8 ball near the bottom left pocket. At a constant speed, the cue ball travels in a straight path towards the 8 ball. The amount of speed that the ball has along the x direction is 3/4 meters per second. The amount of speed that the ball has along the y direction is unknown. Okay, so what does that mean, x and y direction? Well, we have to see the coordinate system to ensure. Okay, the coordinates of the 8 ball are shown in the sketch below. All right, so write the position function for both coordinates of the cue ball, assuming the student shoots at time t equal to 0. So this is hard to imagine without the sketch. So I'm going to go ahead and draw the sketch for you. We drew it in class, and I told you to put it down, so hopefully you did. Okay. So what I'm going to do is go ahead and leave for 1 second and get an example of the homework so I can write down the coordinates correctly. Okay. I had a huge pile of papers. Okay, here we go. All right. So it looks like the coordinates are equal to, let's see here. I think you guys might have kept number 3. So if you have the coordinates for number 3, you can send them over. Yeah, I think everyone kept number 3 when they handed it in. Fortunately, I don't have a copy of the sketch with me. That's okay. I remember it pretty well. So let's go ahead and sketch it. And we'll just put in some example values. It would be unfair to others if I put in the actual values and solve the whole problem anyway. Okay. So here is the sketch accompanying this problem. All right. So let's go ahead and draw it. So here's number 3. We have ourselves a pool table here. So let's just draw it. That. And the interesting thing about this problem is it's a 2-dimensional problem, right? Although we could reduce it to a 1-dimensional problem if we pick the right coordinate system, right? But the purpose of this exercise is to start to get used to coordinate systems in 2 dimensions, right? Not just to use 1. However, when you've mastered 2-dimensional coordinate systems, you're more than welcome to solve this problem with a 1 coordinate system. All right. Let's see here. So we have the cue ball here, and we have the 8 ball somewhere down here. 8 ball. Let's draw a little weight. Circle it. 8. And circle it. Okay. And the coordinate system we are using is going to be something like this. I believe I put the origin right at the center of the cue ball, which is right where I want it. And I believe I had this coordinate system set up so that positive x is right, positive y is up. And let's see here. Oh, I have it. Okay, so somebody did put in the coordinates. That's fine. The coordinates are negative 1.22 and negative 2.6. Okay. Very good. Alrighty then, so after this I'm going to wrap up and I'm going to have to go. But unfortunately, for time's sake, it's taking, we're already almost over a half hour. So anyway, let's go ahead and look at this picture. Alright, here's the cue ball. We want it to the 8 ball, and we're given information about its velocity in each direction. Now we remember from class that the 2-dimensional position function is like this. X of the general form is like this. X of t is equal to Vx t plus the initial x coordinate, x at the time 0. When I say initial, I mean at time t equal to 0. And the y coordinate here, y of t, is given as a function of time by Vy, the velocity along the y direction, times t plus y at the time 0, the initial y coordinate. Okay? Very good. And so, okay. And so let's go back to the question with this picture in mind up here. So let's look at it one more time. There's our coordinate system. And once again, I picked an inconvenient coordinate system just so I had as many minus signs as possible. Just so you can get used to minus signs because we have to get used to dealing with those. All right. It looks like I got one more viewer in the past minute or so. And so once again, you can go ahead and click in the description below and join the chat room if you have any specific questions. As we're wrapping up this video, we're working on number 3. And here's the sketch of the table. All right. And let me bring up the question. Okay. And so the first thing is to write the position function for both coordinates of the cue ball, assuming the student shoots it at time t equal to 0. Okay. So let me get you started here. At time t equal to 0, let's label that on our picture. Right? Is where when the cue ball is here, time is equal to 0. Okay? And then it's going to move in some trajectory, right? Some straight trajectory from here to here. Okay? So, looking at the general position function for x and y of t, we are told that the speed along the x direction, let's see here, is, in the description of the problem, it is 3/4 meters per second. Okay, 3/4 meters per second. 3/4 meters per second. All right. Let's go ahead and put the label like this, and this is in x. Okay. And in the y direction, it is unknown. So Vy is unknown. Okay. Now let's look at the coordinate system, and you can see that this ball is traveling at a constant speed in the negative x direction, right? So this velocity term has to be negative when I plug it in. All right? So we have x of t, let's just start with what we know, is equal to Vx, which is 3/4 meters per second. So assuming x is in meters, I don't need to put units. And now I'm going to put a minus here since I'm traveling in the negative x direction. Okay, see? The x direction goes to the right, and my cue ball is traveling to the left. All right? So we have a minus for that velocity term. The t remains the same, plus the x-coordinate at time t equal to 0. Just look up here. At time t equal to 0, my x-coordinate, well, I'm at the origin, so it must be 0. So, plus 0. Or, in other words, we have nothing here but this. Right? All right. And once again, if you have any questions, just jump into the chat room, sign in as a guest. The chat room is linked in the description below the video. All right. So let's write y of t now. So that's x of t. That will only give us the x-coordinate of the billiard ball as a function of time. So that will only tell us, so let's draw the negative x-axis just to clear it up. So we have negative x going this way in the opposite direction of positive x. All right, it's negative x, right? This is the origin of x, so x equal to 0 there. So what x of t will give us, which is what we just wrote, is just the x-coordinate that the billiard ball is at as a function of time. So it just gives us little positions on this axis. However, it will not tell us how far down the ball is at any time. In order to pinpoint that location of how far down it is, we need the y-coordinate as a function of time, right? Now here, the ball's traveling in the negative y direction. We don't need to put that information in because we have Vy is unknown right now. So y of t is equal to Vyt plus the y-coordinate at time t equal to 0. What's the y-coordinate of the cue ball at t equal to 0? Well, we're at the origin, right? We're at the origin, so it's 0. And so plus 0 is just that. So we have these two functions, okay? That would be my position function. That would be that part. So let's go ahead and bring up the homework once again. Just look at the rest of the questions, and I'll just go through them verbally and leave it to you to figure out the rest. I don't want to spoil too much of the homework for those of for the classmates who don't see the video. All right. How long will it take for the cue ball to reach the x-coordinate of the 8 ball, right? So we have an x position function which gives us x as a function of time, right? So we don't know how long it will take, but we'll say at the time capital T, x will be at the same x-coordinate as the 8 ball, which I've written in the sketch is negative 1.22. That would be the x-coordinate. So you then solve for time. Okie dokie. And then what will be the speed along the y-axis? With what speed along the y-axis must the cue ball travel in order to hit the 8 ball, right? So it's sort of like a puzzle here. You have to use the fact that y at the same time, right? The same time it takes to get to that x-coordinate, right, needs to be the same time that it reaches the y-coordinate. So try to use that information to solve for that unknown Vy, that unknown variable Vy, all right? So let me just point it out here in our work down here. Alrighty. So we got this position for a function of time for the cue ball with an unknown variable Vy here, so V subscript y. So So let me get you started. Let t be the time when cue ball hits 8 ball. Okay. And from here, if you write this, the fact that the cue ball hits the 8 ball at this time, right? So x at the time t must be equal to what x coordinate? And y at the time t should be equal to what y coordinate? Remembering these times are equal, these capital T's. Okay? That should be enough to get you started. I'll be just sort of lingering here for a few seconds. Some people want me to spoil, Mr. Saeed wants me to spoil the problem. That's okay. I don't think I'll do that. I'll leave the fun up for you, for you to figure out. But if you have any specific questions, let me know now. What I'm going to do immediately after this video is post these notes that I took, okay, onto RenWeb. So right now, I'm going to go ahead and do that. I'm going to wait about 30 seconds here. And if I don't get any questions in the chat room, then I'm going to go ahead and take off. Alrighty. But anyway, I'll post these notes onto RenWeb. I'll call them Video Notes 1, and that way you can access the notes at any time from this video without having to go through the video where I scroll up and down all the time. All right? Okay, thank you guys for tuning in. Sorry it took so long. Still getting used to everything. But by the end of the year, should be a pro at this. Alrighty. Everybody have a good night. Good luck on number 3. Shoot me an email if you have any questions. Alright. Bye.